Welcome to June. All right, let's see if we're live streaming. A little bit of a glitch there. Welcome to June. We're winding down our probability unit. So that means we will be starting precision measurements soon. And you can, of course, let me know when you're ready to write your probability test. We learned about odds last week. And odds are just a different way of expressing probability. I would say that it's used less than probability. We're more familiar with being told that there's a 30% probability of rain, or there's a 4 in 5 chance or probability that you might end up with a cold, things like that. So odds are, to me, I've most encountered the word odds and the use of odds in a gambling context, which we don't really talk about or use in school that much. So I'm going to go through the examples for lesson 5. And in lesson 4, we learned what odds were. And today we are going to be converting back and forth between odds and probability. So now that you're familiar with both odds and probability, you need to learn how to convert one to the other and back again. Recall that probability is a fraction that compares favorable outcomes to total outcomes, while odds compares favorable to unfavorable, right? To favorable to undesired. Both are shown below. So probability equals favorable outcomes, or whatever you're looking for, divided by the total. And odds are just favorable to undesired, or favorable to unfavorable, I suppose. Notice the difference, right? This is displayed as a fraction, which can be turned into a decimal or a percent, right? So it's one fraction, one decimal, 1%. Here it's just odds are a number against a number, right? Success compared to failures. That's another way that we can express what odds are. Oops, maybe I'll put an equal sign. Odds are successes compared to failures. You're just comparing the two possible outcomes, basically. You're taking the outcomes and dividing them into two parts. Okay, so today we're just going to move back and forth between the two methods of presentation. We're going to change probability to odds, or odds to probability. Hey, Cynthia, nice to see you, or sort of see you. Example 1, a bag contains 3 gold coins, 8 brass coins. You choose a coin at random. So that means you're not dipping your hand in and on purpose taking a gold. You're kind of dipping your hand in without looking in the bag or with a blindfold on, and you're just pulling out a coin. State the probability of choosing a gold coin. Okay, you have to pay attention to what you're asked for. You're asked for the probability. That means I'm going to display it as a fraction, decimal, or percent. In this case, I think it's easy just to present it as a fraction, right? So the probability of getting a gold is, okay, how many gold do I have? 3 and 11 coins in total. Okay, I know I did this quite a few times in the last lesson, identified what the numbers mean, and I'm going to do that this time too. Number of gold coins, just to refresh your memory. And this, once again, in probability, the bottom number is always the total number of coins. All right. Now, the next two are asked for odds. Therefore, my answer is not going to be fraction. It's going to be one number compared to the next. So this would just be 3 to 8. And this is how I always describe my odds. This is the number of gold coins. So when you're looking for the odds of something happening, the numerator is going to be the same as the first number. And this, I'm going to describe it in a different way than you might think. This is the number of not gold coins. Now, I could have said brass coins, but in this example, we just had the two categories, but this becomes very important to think of this second number in this way, because if there was a third type of coin, the brass and the other type of coin would be totaled up in this number. So I prefer to describe it as whatever you're looking for, that's regarded as a success, failure, gold, not gold. And then state the odds against choosing a brass coin. Okay, the odds for choosing brass would be 8-3. So again, the odds against brass, we do, this is how we go. We go not number that are not brass, number that are brass. Okay. So odds against, you put the ones that aren't whatever you're looking for, right? That are against Brad. There are 3 against Brad, 8 for brass. Sorry. Brass, not Brad. Okay, let's take a look at example 2. Just chime in if you have any questions. Example 2, the probability that the Winnipeg Jets win a game against the Capitals is 4 out of 11. State the odds in favor of the Jets winning a game against the Capitals. Okay, so once again, this is the total number of wins, because this is the probability of winning. And this would be the total number of games. Therefore, odds in favor of Jets winning, it's going to be 4-7, right? And this would be the number of wins. And this would be the number of, well, not wins. So I'll just call them losses, right? And how did I get that 7? Well, it's pretty straightforward, I think. 11 take away 4 is 7, right? This is the total number. Total wins, losses. Okay. We're not, because games basically end in a win or a loss because they play overtime for ties. So they either win or lose. And if they win 4, they have to lose 7 if there's only 11 games in total. Okay. So let's flip over the page and let's take a look at what's on the next. Whoops. So the next page has a couple of other examples. Let's see what this is. The odds that Tara will be late for school on any given day are 4-3. State the probability that Tara will not be late for school. Okay, what are we looking for? We're looking for the probability. The odds that she'll be late for school or any given day are 4-3. The odds she will be late. So this is the number of lates. And the opposite of lates is on time. This is the number on time. Or I should say not late. Okay. State the probability she will not be late. Okay, so probability of not late. Well, what's the number of not lates? The number of not lates is 3. The total would be 4 + 3, 7. Okay? So just remember this is 4 + 3 = 7. These are the lates. These are the not lates. So we only have 2 categories. 7 is the total. Okay. State the probability that, the probability that it will rain tomorrow is 12%. State the odds in favor of it raining. Well, remember percent is a percentage. The highest percentage is 100. So it would be 12 to, let's see, what's 100 take away 12? $88. And I'm just going to do a little aside here. 100% take away 12% equals 88%. Together, the whole, an entire amount can't be, if we're talking about a quantity, can't be greater than 100%. So rain, it's either going to rain or not rain. That's it. If we think in that context, right, either rain or not rain. State the odds against it raining. Well, if the odds in favor of raining is 12 to 88, odds against, we just flip. This is 88 to 12. Okay, if the odds against it raining, that means rain comes last and the other option comes first. So it's an easy enough concept. It's easy, however, to get tangled around, right? It's quite simplistic, but sometimes the numbers can throw students off. So there's a big assignment. I am going to give you some time now to work on assignment 5. There's a big, like I say, it's a big assignment. We have lots of time because the examples didn't take that long. So I think what I'm going to do is, like before, like I've been doing, I'm going to give you some work time. Kind of chunk away and keep working. I've been doing this for a little while now, so you're probably a little used to my system here. And I'm going to say, work on assignment 5. I'll go over questions every 10 minutes. Okay, so I'm going to assign in the next 10 minutes, so like at about 20 after, I will go over, let's see, how about 1 to 5? I'll go over 1 to 5 because they're kind of short snappers. So 1 to 5. So I'll see you in 10 minutes. Okay, so I'm going to go over the first 5 questions, and I'm going to see if I can just put them on here. The answers shouldn't be that big, so I think I can squeeze them on the paper, but we'll see. Assignment 5. So this is converting between probability and odds back and forth. So number 1, Sam competes in mixed martial arts. His probability of winning is 4 out of 7. State the odds of winning. Okay, these are the number of wins. If he wins 4 times and there's only 7 matches, that means he loses 3 times. Okay, so wins to loses. State the probability of losing. Okay, so the probability of losing, this is when I do my little capital P, whatever I'm looking for. So the number of losses is 3, total matches is 7. Okay. Hey, Cynthia, if you have time, can you just hit me with a chat back and say, let me know if the streaming is still clear. Because I think it's been pretty clear since I switched devices. So just let me know if it's still nice and clear, if you can. State the odds of losing. Okay, well, if winning is 4 to 3, then losing has to be 3 to 4. Okay. A basketball team has a probability of winning of 0.7. Express this probability as a fraction. All right, well, this is, if I think of this, 0.7 is, if I want to convert 0.7 times 100, if this is my decimal, and to convert that to percent, remember I just multiply by 100, that gives me 70%. Okay, so one of the ways I could express as a fraction is just, this is the same as the fraction 70 out of 100. Okay, I haven't noticed any. Perfect. So ever since I switched my devices, it's been great. I wish I would have done that at the beginning. Thank you. State the odds of winning. All right, the odds of winning, I could just express this as 70 to 30. Or 7 to 3. There's other ways of expressing odds. If you have any other ways, you can run them by me. But to me, it's easier just thinking of this, like taking any decimal, converting to percent, then I can kind of make sense of what that number means a lot easier. The odds of 3 teams winning a league championship are shown below. So there's the red, the green, and the yellow. State the probability of each team winning the championship. Okay, probability of each team winning. So probability that red wins, this might be hard to cram in, equals, okay, so 5 wins out of 7 games total, 5 plus 2. 5 plus 2 equals 7 games in total. 7 plus 3 equals 10 games in total. And 15 plus 4 equals 19 games in total for the yellow. Okay, probability that green wins is 7 out of 10. Probability that yellow wins equals 15 out of 19. Okay, which team has the best chance to win? Well, I think what I would do, 7 to 10 and 7. Yeah, that's perfect, Cynthia. That's great for number 2. So I think what I'm going to do is I'm going to convert them all into percents. Okay, so I'm going to go do 5 divides 7 times 100. And that gives me 71%. I'm just going to round to the closest. I know that's 70%. Now you might not have had to do this, but for me it's easier to, and this rounds to 79%, right? So yellow has the highest percent of winning, so yellow has best chance. 79%. So yellow seems to be the strongest team, and then the red, and then the green. Okay. The probability it will snow today is 60%. State the odds it will snow. Well, that would just be 60-40, because together 60 and 40 make 100. And then number 5, the probability that Joan buys a red car is 0.35. State the odds she buys a red car. Now, you could leave this as a decimal number and do your odds in decimals. I personally like percents better. So I'm just going to say that this is 35%. 0.35 is 35%. State the odds she buys a red car. So it would be 35, 65. Because together 35 and 65 make 100. Right? 100% minus 35 is 65. Okay, I'm going to stop for a moment, and I'm going to say, keep working, do the next set of 5. So 6 to 10. I'll give you another 10 minutes, maybe at 12:35. I'll keep doing these in chunks. Okay, see you in 10. Okay, I'm back. I had done up to 1 to 5. So now I'm going to work through 6 to 10. Again, we're just working between odds and probability. So number 6 states, the odds of the horse named Breezy Wind running his race at Assiniboine Downs are 3 to 2. State the probability that Breezy Wind will win the race. So I'm looking for probability. So probability that he'll win is, well, this is the number of wins. The total number of races would be 5. Anytime you're finding probability, you have to add your two odds numbers and total them up to get the denominator of the fraction. A sports betting agency has put the odds of the Jets making the playoffs 5 to 7. State the probability they will not make the playoffs. Okay, not make playoffs. Well, this is the number of possibilities that, or the number of not playoffs that they will get. This is the number for the playoffs. This is the number for not playoffs. So it'd be 7 out of 12. A little better than 50%. The odds that the next car out of the parking lot is black are 4 to 5. The odds that the next car out of the parking lot is blue is 2 to 7. Which color car is the greater probability? Okay, I guess we have to figure both probabilities like we did in that previous question, number 3. So the probability that the car is black is 4 out of 9. The probability the car is blue is 2 out of 9. Well, I don't have to even do a percentage, do I? I know 4 out of 9 is greater than 2 out of 9, right? I mean, you could convert to a percent, but I know 4 chances in 9 is a higher probability than 2 in 9. So this is greater probability. Okay, number 9. In a class of 30 students, 12 take art, 11 take music, and the rest take drama. Okay, so what would the rest be? Let's see, the rest take drama. 12 and 11 is 23. So I'm just going to put in brackets 7 take drama. Just so I know. Because 7 and 11 is 18, 18 and 12 is 30. Okay, state the odds in favor of the student taking music. Well, 11 take music. Therefore, 7 and 12, 19 don't take music. State the odds against taking art. So then art is the last number. And 11 and 11, it would be 20. Sorry, I don't think it's 20. Hang on. 30 take away 12. Whoops. 18, right? So it's 18 against 12, right? 7 and 11 make 18, 18 to 12. Odds against taking art are 18 to 12. State the probability that the student takes music or art. So music or art, music and art are 23. So probability, music or art is 23 out of 30. State the odds. Now, I guess just to clarify something, this must be an option and the students get to pick one of these, right? It doesn't seem like there's overlap. They get to take one from the arts category. State the odds in favor of taking art or drama. So let's see, how many take art or drama? 12 and 7 is 19. So that would be 19 against 11. And then finally, number 10, Bob is tossing a coin. He tells you the probability of tossing heads is 1 to 1. Do you agree? Let's see. If odds are 1 to 1. That means probability of heads is 1 out of 2, which is correct, right? So yes, Bob is correct. For a coin toss, the options are, head or tail. That's how we define them. So which is 1 to 1 odds. And how we define that, right, is number of heads, number of not heads, right? Tails. So it's 1 to 1. He's correct. 1 to 1 would also be probability 1 out of 2, which is the probability of getting heads on a coin toss. So that's 6 to 10 done. We do have a few minutes left, so let's see what we can get done. I'm not sure how much we can get done in the last 20 minutes, but let's see. I might even end up running just a little bit over your class and then starting my next class a bit later. He's right, but I'm angry that he doesn't express it as a fraction instead of ratio. I know, it's kind of a weird way. Most people would say 1 and 2, right? Okay, let's try the next set of questions. There's only 3 of them, but they have many parts to them, so it's a little more, it's going to take a bit more time. But work for the next few minutes, maybe the next 15 minutes on those, and then I'll go through these before we leave class today. Okay, so I'm going to finish up the last few questions. So you have these, and then I'm going to assign the review for you to work on tomorrow. And I won't do a video tomorrow. I'll just let you have a work class tomorrow. And I mean, you can email me if you have problems and stuff, but I think that's what we'll do. And then let me know if you have a test, and then we'll finish the probability unit midweek. Each letter in the word mathematics is placed on a different card. The cards are placed face down on a table and mixed up. State the odds in favor of selecting M. Okay, I guess I have to figure out how many M's there are. There's 2 M's. And how many not M's? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 not M's. That means there's 11 letters in total. And 11 letters in total. State the probability of selecting an M. Probability of an M is 2 out of 11. State the odds against selecting an M. Well, if odds in favor are 2 to 9, odds against are just 9 to 2. State the probability of not selecting an M. Well, probability of not M is, well, if there's 2 letters that are M's, the rest are not M's, so that it's going to be 9 out of 11. Explain how the answers in C and D above could be found by using the answers in A and B above. So C and D, they are just, I'm going to say, the complements. Remember that word, complements of A and B. I'm going to say, well, 9 out of 11 is the complement of 2 out of 11. And 9 to 2 is the opposite, right? Opposites are complements. At the casino, you see a spinner like the one shown below with 12 sections of equal size. You pay $2 to spin the wheel. You win the amount of money shown on the space under the triangle pointer when the wheel stops. State the probability of winning nothing at all. Okay, probability. So probability of 0 equals let's see, you pay $2 to spin the wheel. You win the amount shown in the space. So I guess probability of $0 equals, okay, this is a bit tricky, huh? Win nothing. I don't know what the back says. If you spin, I'm just going to double check this for a sec. I want to check the answers. But if you spin $0, $1, or $2, you win nothing. And as a matter of fact, you lose money, don't you? Okay, that's good, Cynthia. Okay, so I think this should say spinning 0. I think probability of spinning $0. Because probability of winning nothing, even if you spin $1, you're going to lose money. Okay. You win nothing if you spin $0. Okay, so probability of spinning $0, 1, 2. 2 out of 12 in total. State the odds of winning nothing at all. Well, that's just taking my probability. So 2 against 10. State the probability of winning an amount of money that is less than you originally bet. Okay. So less than what you originally bet, that would be 1, 2, 3, 4, 5, 6, 7, 8. So this would be the probability of $0 or $1 is 8 out of 12. State the odds of winning the top prize. Okay, how many top prize? There's only one top prize. So there's one top prize and 11 not top prizes. 1 against 11. State the odds of winning at least as much as you bet. Okay, at least as much as you bet. That means the probability of winning $2 or $10 or $20. Okay, so all of those are at least, oh, sorry, yeah, 2. I can't include the 1 or the zeros because they're less than what I bet. So how many 2, 10s, or 20s are there? 1, 2, 3, 4. It's going to be 4. Sorry, it's the odds. So it's 4 against 8. 4 slices have $2, $10, or $20, and 8 slices only have $1 or $0. Challenge question, determine the expected value. Okay, I'm going to come back to this game or to this question. I'll finish these and then I'll come back to that one because it's a challenge. Random testing shows that 20 out of every 1,500 are defective. State the odds in favor of a light bulb being defective. So 20 are defective. How many are not defective? Well, I have to take 1,500 minus 20 is 1,480. Right? 1,500 minus the 20 equals the 1,480. That's the complement, right? Defective, not defective. State the probability of a light bulb not being defective. Okay, so not defective equals, well, there's 1,480 not defective, 1,500 in total. A company produces 50,000 light bulbs. Determine how many light bulbs you would expect to be defective. Okay, well, 20 out of 1,500 are defective. So 20 out of 1,500. So this proportion, let's see what 20 out of 1,500 are. It's about 1.3%. So 20 out of 1,500, and I could do my cross multiply, right? Well, I want to convert that. These are the defective. These are the total. If I change my new total to be 50,000, and I just want to find my new number of defective. So just like I do with all my cross multiplies, I multiply that to diagonal numbers and divide out the number left over. So x equals 20 times 50,000 divided by 1,500. Whoops. We expect 66.67, or I'm going to say, you can go either way on this one. I'm going to say 66 will be defective. Did I do something wrong here? Hang on. I think I might have forgot a 0. So 20 times 50,000 divided by 1,500. Yeah, that's better. 666. So 600, you can go either way, 667 or 666, because you might say, well, it's not going to be, it doesn't make a full light bulb, so either one is fine, will be defective. Okay, one other thing, let's try and get through, I'm just going to go a couple minutes over, and let's try the challenge question, which is F. Now I'm running out of room here. So what I'm going to do, so I'm just going to move up here. I'm going to do F up here. All right. Determine the expected value for this game. So remember what expected value is? Expected value equals the probability of winning times the amount won minus the cost. Now in this game, actually a lot of different ways to win, right? I could either win $1, I could win $2, $20, or $10. So we have multiple ways to win. Well, we know how to handle that, right? So the expected value would be equal to, all right, the probability of winning, or the probability of spinning $0 equals, okay, well, let's do this. 1, 2, 2 out of 12. Whoops. Actually, I'll write the formula. I do the probability of winning $0 times $0, right? Or I can do, so this is one way to win. The probability of winning $1 times $1. That's another way to win. Or there's the probability of winning $2 times $2. It's another way to win. You know what? Sorry, guys. I'm going to redo this. I'm going to make this a little easier. I don't want to mix people up too much. So I'm going to backtrack this. Just want to find my eraser, which I can never find when I need it. So I'm just going to erase this for a second. Just because I'm running out of room here too. Sorry about that. Ignore this for a sec. So let's just record all the ways to win money. How can I win money? I can win money, the probability of winning, I've got the probability of 0 is 2 out of 12, right? I can win $1. 1, 2, 3, 4, 5, 6. That's 6 chances out of 12. I can win $2. And that's 1, 2 out of 12 again. I can win $10. And there's only one of those. And finally, I can win $20. And again, that's 1 out of 12. So I should have all if I add up, 2 plus 6 is 8, 9, 10, 11, 12. So I have all my ways of winning identified. So the expected value equals, okay, so I have 2 out of 12 times the amount 1, which would be $0, or 6 in 12 chances of $1, or 2 in 12 chances of $2, or 1 in 12 chances of $10. I have to move down here. Or 1 in 12 chances of $20. So if you kind of look close, here's my probability of winning $0, probability of winning $1, $2, $10, or $20. Okay. And then I have to take out the cost, and the cost is $2. Now, when I type all that into my calculator, let's see what we get. 2 divide 12 times 0. Well, that's easy. Plus minus 2, and we get $1.33. Okay. So that's the expected value of this game. So the expected value is positive. That's a good sign. Then you could be okay in playing it for a couple spins, because you're not expected to lose money, you're expected to gain money. Okay, that is it for today. I'm going to do my next class. So I will tomorrow, I'm just going to give you a work class and you work on the unit review. Okay?